Okay, next we're going to create our vPC domain. So we'll say this is domain number 2. And the peer keep alive destination, this is going to be some sort of layer 3 address that exists on the remote device. Now again, as we talked about previously, this could simply be the management port. So we have the switches connected on management 0 to an intermediary switch that we have IP connectivity over, or this could be an in-band data plane port that's either running as a native layer 3 switch port or running as a switch virtual interface. Now in the case of the 5Ks, the 5548s or the 5596, which is this particular platform, these normally do not support layer 3 routing on their own unless you have this layer 3 daughter card plugged into the expansion module. So the first generation, the 5010s and the 5020s of Nexus was layer 2 only. The second generation was mainly layer 2, but layer 3 with this add-in card. The third generation, the 5600s, is native layer 3 support on all of the interfaces. But in our particular case, both of these switches don't have the layer 3 ASIC, so we're not going to be routing to reach the keep alive. We're just going to be using the management interface. If we look at the show IP interface brief in VRF management, our addresses are 192.168.0.58 and 192.168.0.57. So as long as we can ping the remote box 58 in VRF management, we should be able to use this link for the keep alive. But again, we need to make sure that the layer 3 connectivity is there first, because the vPC peer link for it synchronizing the control plane will never come up unless the peer keep alive link exists to begin with. Okay, so let's go back to the vPC domain, and we're going to specify, so vPC domain 2, we're going to specify the peer keep alive destination. So this is the other switch's address, and by default, again, we can see it's going to use the management VRF. Same thing on the other side. We'll say that under the vPC domain, the peer keep alive destination is the other switch. And if we look at the show vPC, we should see now that the peer is alive. Okay, so that's our first step. Okay, next step is we need to establish the peer link. Peer link, again, is where we're going to synchronize the control plane. So in our particular case here, we have these interfaces that are connected between the two switches. So we have interfaces E1, 3 through 5. We're going to use this as a layer 2 port channel. So again, basically a layer 2 trunk that we're using to synchronize all of the VLAN control plane information between the switches. So the peer keep alive link is layer 3, but the peer link is layer 2. Okay, so let's go to this particular port. Let's actually show run on it first. Show run interface E1, 3 through 5. And right now, this side is configured as a trunk, and the ports are shut down. So just like any other port channel, we need to make sure that the configuration of all the members is the same before we try to put them into the to the ether channel or to the port channel. So we'll say on interface E1, 3 through 5, these are going to be in a channel. We'll say channel group 2 mode is active. And again, the mode here is specifying that we are running LACP, the Link Aggregation Control Protocol. Okay, next step, we're going to go to the port channel and tell them that this is the vPC peer link. So that's where we're synchronizing the control plane. Same thing on the other side. We'll say interface E1, 3 through 5 is going to be in a channel. Port channel 2 is the vPC peer link. And then we'll activate these interfaces. So E1, 3 through 5, we'll say no shutdown. And then like any other channel, we're going to look at the show port channel summary to make sure that the members are actually up. So the peer link, it's going to take a couple seconds for it to start to bring up and to synchronize the control plane. Ultimately, what we should see here once it is correct is that we see it's a layer 2 switch port. This should be up, and we should see the ports have capital P, which means that they're members of the port channel, which we do. Okay, next we're going to look back at the show vPC again. And what we should see is that the peer adjacency is formed. So now we have the basic prerequisites in order to channel down to the members, which are the end hosts. So we have the layer 3 keep alive, we have the layer 2 control plane synchronization. Now we can configure the channel down to the destination. So from 5K8's point of view, this is going to be the port that physically goes down this way. So this is going to be on E10211. On the other side, this is going to be E10111. So if we look at the particular port show run interface E10211, we're going to say that this interface is in a port channel. So we'll say channel group. We'll say channel group 3, mode active. And the mode here again depends on what the end server is running. Most normal OSs nowadays do support LACP in the NIC drivers, so generally you would want to enable it. For some older deployments, you may see that you have to set the channel mode to be on, which is a static port channel. But again, the disadvantage of that is that if there is a process level issue, you could end up having a layer 2 loop in the network. So LACP is kind of that extra cushion to make sure that there's nothing wrong with either the layer 1 or the layer 2 process. Okay, and then we'll simply say no shutdown. Okay, the port channel in this case, we're going to put it into an access VLAN. So we're going to say switch port mode is access, and the switch port access VLAN is 10. So same thing on the other side. We'll say interface E10111 is going to be channel group 3. Channel group 3 mode active. Port channel 3 is going to be a access switch port. The switch port access VLAN is 10. Then last but not least, we need to specify that this is a virtual port channel member. So if we issue just the vPC command on its own, the number will be inherited by the port channel number. So in this particular case, it means it's vPC number 3. You can again also say explicitly that this is vPC 3 or give it a different value. But for clarity of operations, you would normally match these two numbers together, the port channel and the vPC number. Okay, so our final verification then, if we look at the show vPC, we should see now that port channel 3 down to the final destination should come up, which it does. Okay, if we look at the show port channel summary, we see now that we have the fabric extenders port as a member of the channel, and this should also be synchronized with the other vPC peer. So essentially, since the fabric extenders ports look like a directly connected line card, there's really no configuration difference between the host-based VPC or a VPC that was directly connected on our server ports. So from the end operating system point of view, we should now be able to send traffic out the channel. So if we ping 10.0.0.7 or 10.0.0.8, those are the other servers that are on this particular VLAN. And from the 5K's point of view, if we now look at the show MAC address table dynamic for VLAN 10, we should see that the NIC team has a MAC address that is now learned on the port channel, in this case, port channel 3. So if we were to look at this from both switches' point of view, show MAC address table dynamic for VLAN 10, we should essentially see that the MAC address information out the port channel is going to be synchronized between the two of them. So again, this is a key point of the VPC's operation on the back end. If the switches do not agree how to do layer 2 forwarding for the member port, that's where we can end up in a layer 1 loop. So they have to synchronize this information over the peer link. If the peer link were to go down, we're going to simply disable the ports to the destination, to the member, in order to make sure that we don't have a looping situation.